Yeah. Hey, awesome. Hey, Ron, thanks for having me. It's great to be here. I'm really excited for the chance to talk with you about yeah, Llama 4 and some of the other directions in our research. Yeah, let me just share here. Can you see the slides?
Yes, we can see the slides. Just for you to understand, there are about 40 people here in Lviv, Ukraine, listening to you. We're in a safe space in an underground under auditorium, and another 30 people on Zoom.
Okay.
Yeah, we can see and hear you well. We're waiting for your talk.
Amazing. And just logistically, questions will be at the end, or do you also
Yes,
want
the
to have
questions will
questions?
be at the end. We are using Slido for the questions, so same as you have seen now. We were asking Mikola. Yeah.
Hmm? Okay, okay, fantastic, yeah. So yeah, hey everyone, it's great to be here. So yeah, in this talk I want to talk to you a bit about Llama 4 and some of the like modeling considerations and evaluations that we're using as part of developing Llama 4 as well as the Meta AI assistant. And then also I want to talk more broadly about the kind of how I see the broader future of multilingual modeling with applications to Ukrainian as well to really develop models that can be useful for each and every speaker of the different languages. And so in terms of my agenda, I'm going to give you a brief overview of Llama 4. I was originally, when I created or submitted the proposal for the talk, planning to talk a bit more in depth about this, but the Llama 4 tech report is not public yet, so I will keep this part a bit lighter than I originally expected, but happy to answer more questions on this later on. And for the main part of the talk, I'm going to focus on essentially trying to connect or bridge the academic landscape of how we evaluate models or how we think about model evaluation across languages to some of the considerations that we're dealing with in industry in terms of developing models on that are trained and evaluated on real world user interactions that ultimately should be useful to speakers and users of those different languages. Um, so with that in mind, some of you might have probably already heard, right, that the Llama 4 models have been released in April. Llama 4 is the latest iteration of the Llama series of models, which I think before up to Llama 3 had been downloaded more than 1 billion times on Hugging Face. And the difference with these Llama 4 models now is that the architecture shifted from a dense focus to a mixture of experts, as well as before, for some of the later Llama 3.3 iterations, there was kind of a late fusion of text and multimodal models. And for these models, the Llama 4 models have been developed with multimodality as well as speech in mind from the get-go. So they are trained kind of in early fusion and combining both text, multimodal, and speech data as well. And yeah, the focus really on these mixture of experts models was essentially driven by the intent to develop models that are useful in large-scale production settings, where these mixture of experts parameters, due to the small number of active parameters, is going to be more efficient at inference time. And so there's two variants of those models available: Scout with a like smaller number of total parameters and the larger Maverick model. With Scout kind of being trained or being optimized to be used for inference on a single H100. The downside with going for a mix of experts architectures for these models is that they're less useful or less easily hostable in kind of more local settings or in compute constrained settings that we also have in academia or just for like smaller developers, which is kind of a downside of the current set of models. But I think there's going to be I think down the line some new models hopefully at some point that fill in some of these gaps to again give us like the same level of performance with these models, but also the same level of usability even in smaller scale settings that we've had from the previous generation of Llama models. And the kind of overview here, I mean, with the latest generations of these models, there is kind of less innovation on the like architecture, like on the fundamental side. Most of the work goes into actually like the data and the data curation. This time, yeah, just for the model, it's been trained on data across different modalities and with a lot of distillation in pre-training. While post-training, as in with other recent models, is kind of a combination of SFT, different forms of remote modeling, rejection sampling, RL, and DPO. And just briefly, the model is just a standard decode-only transformer in a mixed group experts architecture. In this case, not only trained on text, but on multimodal tokens in an autoregressive decoding setup. I think on the blog post, they shared some results of the model. So generally, it outperforms the previous largest Llama models across most tasks that we evaluated, while having this smaller number of active parameters, which makes inference faster. And it's particularly strong in the new kind of natively integrated vision capability compared to prior models. On some of the evals that we've evaluated, it's also competitive with the leading closed models, although I think there's still some room for improvement. And I think similar to the previous iteration of Llama models, where there was like the initial base model, but then like 3.1, 3.2, which has had some improvements. We can expect there to also be further versions of these that make this more useful or more tractable for different usage scenarios as well. And now, just on the kind of multilingual side, how that fits in the picture. Generally, for training these foundation models, right, we want to train general purpose models that are that excel across a wide range of different capabilities. So in practice, there's typically kind of individual teams that focus on each of these capabilities, which focus on developing both evaluation and training to optimize across these capabilities. Furthermore, there's certain capabilities where multilinguality fits in that span kind of all of these vertical capabilities. So things like instruction following or formatting, right, are relevant both for STEM coding as well as other use cases. And similarly, multilingually as well, we don't want to just have a model that is good visually in multilingual, right, but that is also has similar capabilities for like factuality or STEM also at other languages. And so in practice, because each of these capabilities is typically tackled by separate teams, so on the ground this just requires a lot of coordination and staying in sync, and in the end actually trying to optimize all of these kind of different and sometimes orthogonal objectives together to have finally a model that is good at all of these different facets. The current model, I think, officially supports these 22 languages. Ukrainian actually is not like part of this like official list, but I mean in practice, the model, like other models, has been trained on a much larger set of languages. And so we're currently, for instance, working on extending and making sure that we get the same level of language quality on a broader set of languages, including Ukrainian, and which in practice kind of mainly revolves having these languages covered in post-training and making sure that our evaluations that we have available accurately reflect kind of the real-world usage behavior in those languages. And so with that in mind, I already mentioned a bit that we are evaluating models in these languages. So in this part of the talk, I just want to talk a bit more about some of the settings where we've designed some academic study for evaluation, and how this actually reflects or then translates to some of the scenarios or the interactions that we see in the real-world language use with user conversations in industry. And here I just want to reiterate again that for developing any model, particularly with these very large general purpose models, evaluations are really crucial, because in the end, if you can't measure a certain capability or a certain aspect of a capability, you can't optimize on it, and your model might also regress on it or simply like fail. So having a comprehensive suite of evaluations is really crucial for any kind of model development. And so we are, of course, also using academic evaluations, which typically cover kind of major capabilities like factuality or instruction following, and can give us signal whether the model is able to do well on these kind of fundamental capabilities. But at the same time, they don't really reflect kind of real-world usage or how people actually would interact or use this assistant. So in practice, we also need to complement these evals with evals that are maybe designed in a similar way, but actually using data from the product or from real-world user interactions. And then furthermore, because automatic evals, I mean, these days with language model as judges, I think the types of tasks we can reliably automatically evaluate has definitely grown. And I think has also included kind of more subtle or more complex scenarios. But in practice, these like judges also have their own types of biases, and actually having judges that can translate or transfer to new types of even like out of distribution data or new types of languages is still very challenging. So in practice, we still need to complement this automatic set of evals with evals using humans. So both on like general preferences, similar what you might know from Chatbot Arena, where we have annotators look at two responses and assess which is better across in general or across different capabilities. And also perhaps more fine-grained evaluations where we ask questions related to different rubrics that can give us more fine-grained insight about different failure modes of these models. And yeah, in the end, I think all of these kind of evals fill a different need. Automatic evals allow us to get quick signal doing fine-tuning or doing like hill climbing for optimization, while human evals are definitely the North Star and actually allow us to measure whether we're really optimizing and delivering on the actual final use cases and things that we truly care about. And now I just want to illustrate a bit how perhaps some of the differences between some of the evals we have available in academia and the other settings that we care about in this industry setting of working with conversations of real users. And I'm going to use here as an example a study that we did on language confusion. And here the underlying kind of concept obviously is essentially the requirement, for the fundamental requirement for a multilingual language model to understand the user's intent, like in their prompt. And in this case, the intent also includes not just what kind of instructions it should follow, but also the language the user would like to communicate in, or the type of like dialect or form here. And in this context, we define language confusion as a model's failure to generate text in the right language or language variety given the conversation context. So you can see some examples here that essentially express different levels or different levels of severity of this concept, where you have the full response confusion, where you have a prompt in one language and the model replies in a completely different language, most commonly English. We've also observed this on just a line or clause level, where a model might switch within for certain sentences and then continue again in another language, or and this is kind of the hardest setting to detect kind of a random word switching, like confusion on the word level, which is different from the more natural code switching, which like native speakers most commonly do across different languages within utterance. But here in this case, it's basically just more akin to randomly switching for random words in utterance, often to English, and then continuing again in the target language. And we want to study this type of behavior, or essentially prevent this type of behavior, because it just represents a fundamental limitation, fundamental failure mode of the models actually delivering and really understanding the full context and the full intent behind the conversation, and in practice translates to a very poor user experience. And so to evaluate this behavior, we at the end of last year designed a benchmark that consists of a curated set of prompts covering different sets of languages and different sources, both from human translated and human generated data, as well as covering prompts across different complexities, so very simple prompts, as well as prompts that have more constraints attached to them. And for this study, we focused on two generation settings. The first one being what I kind of showed before, like the most natural setting that you can interact with a language model, where you ask a question in your native language or your language of choice, and you would expect the model to respond in the same language. So in this case, kind of this language matching, the language expectation is implicit in the original prompt language. But we also look at a more explicit setting where, in this case here, we have a prompt in English, and we insert a language request in request to generate the output in another language, and basically test whether the model is able to understand this request and follow the instruction to generate it in the appropriate language given the prompt. The metrics that we use here, I mean, you could evaluate this with different metrics. You could use even things like accuracy, right, where the model, how many words it gets correct out of a whole response. But in this case, that kind of depends based on the length of the response. And so the metrics that we introduce here are basically just based on the kind of observation that even a single instance of this confusion, even across a very long response, can negatively affect the user experience. So we basically just care about whether there's a single instance in the entire response, right? So if there's a single instance of code switching or of this language confusion, it gets 0, and otherwise we give a 1. And similarly, on the word level, again, we look at if there's any single instance of a word switching in the entire response, in which case we penalize the model. And for the line level pass rate, we use an off-the-shelf language ID model. And for the word level pass rate, we focus on the setting where the model uses different scripts. And we just look at the switches to the Latin script with a kind of very targeted list of words that are commonly not used in this sort of code switching, to really make sure that we have a very high level and high precision word level language ID system here available. And for the evaluation results, we basically evaluated for the study a number of different models from different language families, including kind of prior Llama models, Mistral models, models from Cohere, as well as kind of the GPT models available at the time. And what we basically observed is that even the strongest models exhibit some degrees of this language confusion, right? So there's no model that is 100% perfect on this, which is kind of the baseline or the fundamental requirement that we would actually expect in a natural conversation. And furthermore, we observed that some LMs that were particularly more English-centric, like some of the earlier Llama models, as well as the Mistral models, exhibited this monolingual confusion to a much higher degree. Furthermore, on the cross-lingual generation setting, which arguably is kind of more related to the model's instruction following ability, we observed that generally the scores were lower, and particularly there were several models that had a very large degradation in this case here. The good news with this, with this phenomenon and with this error setting is that they are actually kind of relatively easy or straightforward ways to mitigate that. In particular, if we simply show the model a few instances of this type of behavior as future prompts, we can dramatically improve the performance of the model on this. And furthermore, we also analyzed the effect of English-centric versus multilingual post-training, and we basically observed that if you only do English-centric post-training with these models, that their performance gets dramatically worse. So English-centric post-training, basically by these prior Llama models, was the main culprit leading to this confusion. And if you actually do multilingual post-training, including SFT and preference tuning, you can mitigate this to a large extent. On the cross-lingual generation side, you this still benefits from examples that in post-training that show this kind of instruction following behavior. So if you kind of train it on examples that show or that have similar types of requests, you can also improve the performance there by a lot. And so yeah, so for this eval, basically this was just focusing on these kind of very baseline settings of monolingual and cross-lingual generation, using mostly existing prompts, but synthetically augmenting them with these explicit generation requests. But in practice, this language confusion is also something that we've been observing with Llama 4 or even assistant models. But the challenge here is that real-world conversations are much more complex than our eval previously was able to capture. And in particular, for real-world conversations, users often use multiple languages or may code switch between these different languages. So actually detecting, okay, what is the right language to generate in based on user responses which make or user prompts or conversation history that may contain multiple languages is much more challenging. Furthermore, generally, just even the decision on in which target language variety the model should respond in is really dependent on the intent of the user and the broader context of the conversation. So, for instance, there's certain varieties for Arabic, for instance. Modern Standard Arabic is typically more used in formal contexts. So if you ask the model to generate a email to your boss, right, you would like it to use Modern Standard Arabic. But if it should generate a message to your family or just continue conversation, more casual conversation with you, you might expect it to use either dialectal Arabic variety or Romanized Arabic here. There are also Romanized variants that are often just used for convenience, right? So you might expect the model to continue using them or maybe respond instead in the kind of canonical script for that language. And users use these models for like all kinds of different use cases as well that go beyond just simply asking it to generate text in another language, but may include asking it for an explanation of the text that may be in different language, or inquiring information about a document that may be in different language, or very commonly, right, just asking it to translate a text in a certain language to your own native language. And and then furthermore, I mean, on the long tail of the end of the distribution, there's all kinds of other like phenomenal artifacts, including use of non-linguistic content that may be kind of sprinkled into the conversation, but in some cases, some responses or prompts might just be completely non-linguistic as well. So in general, I think what we've I've read us in terms of designing these evals in kind of a more controlled setting of what we can measure for open source models, and then looking at what is actually required in these real world conversational contexts, that there is really kind of a gap that we need to bridge between to this like more messiness and diversity of natural language usage. And I think in practice for the community, we can maybe take inspiration of that, and for the evals and data that we're designing, kind of look to take into account some of these factors and characteristics, including relying more on native speakers to generate data rather than just using translation, going beyond just single-turn settings and looking towards multi-turn conversations, and just generally going representing more long-form conversations, long-form contexts, including code searching, and also providing appropriate metadata that regarding perhaps the background of annotators and which language variety they speak, or which region of a language they are from, to ultimately allow us to do much more fine-grained modeling in the end. So with that, for the rest of the talk, I want to talk a bit more about how we can go from developing like general multilingual models to models that are useful to users and speakers of these languages in their local context. And I think here, kind of, I think we are all familiar with like breakdowns of multilingual performance across different languages, right? This is just one example from the Llama 3 paper for safety results, where we can see here the performance breakdown based on English and like French, a lot of like common or world languages here. And this is kind of a general practice, I think, that we typically aggregate or report performance for multilingual models. But the problem with that is that this kind of assumes the notion of like standard languages, right? We assume here, okay, the performance on English, like general English, is reflects these numbers. But based on these results, it's often not clear which language variety this actually represents, right? English can differs between British or American or Australian or Indian English. For Portuguese, the differences are even more stark between Brazilian or European Portuguese, and at the same time there are different Spanish varieties, or for Arabic and many other languages. And so I think all of us, as speakers of different languages, are aware that many languages cannot be simply captured by this just kind of standard or hierarchical notion of what a language is, and that there are in fact not really as homogeneous and not as monolithic as we typically make them out to be in our evaluation settings. And I think just one quote to provide here by the Yiddish scholar here, which basically makes the point that the language is more of a social context that really is more based on the kind of social influence or the overall power of the group or the population of that language, rather than of any other kind of linguistic or like formal considerations. And so with that in mind, I think we can think of maybe the space of like how we want to do multilingual LLP in the future, in terms of the level of granularity, how we think about languages and ultimately speakers of those languages. And so I think so far a lot of work has really focused on serving models or developing models on the language level, right, capturing different languages, whereas over time and also increasingly, right, there's increasing work on developing models that work well for particular regions or particular dialects. And we can see kind of this trend ultimately continuing to take into more information about the local context and about how individual speakers of the different languages actually converse with each other. And we can kind of do the same breakdown here, not just on the level of the language or the communication medium, but also in other aspects, such as what information these models capture. So much of the work so far in our community, even in the multilingual space, right, has focused on kind of more general or what is typically English-centric or Western-centric knowledge, because most benchmarks have that we've been using in the multilingual setting have been translated, and so kind of inherit this like very Western-centric focus. But there are increasingly efforts that look more at local and like region-specific knowledge. And again, I think this will ultimately continue to like more personalizing models as well to individual speakers in terms of the particular knowledge that they care about or that is most useful to them. And similarly, a lot of applications that are being designed are kind of defined with like high-level populations of languages or of user in mind, right? General tasks like coding, assistance and support, or chatbots, chatbot assistance, customer service, right? All of these are things that are like general use cases that are useful kind of across the world. But I think increasingly, given that our models are getting more powerful, we can also look to more country-specific usage scenarios with really different groups and different populations of languages, what is most helpful and most useful to them in terms of maybe encouraging or providing support to local business owners, or enabling them to get more support in terms of their legal or financial queries, for instance, and ultimately really going towards representing the personalized usage scenarios of individual speakers. And I mean, I only mentioned these couple of aspects here. I think there's other things like safety that I didn't reflect on here, that also differs in terms of just general notions about what is safe and what is not, and which also has kind of more region-specific instantiations towards, and then ultimately also what individual speakers maybe perceive as being offensive or not. And before I'm going to go down kind of more about, and going to talk more about the middle part of this here, about country and region specific modeling, I want to spend a bit more time also just again talking on the language level, and particularly about issues that we still have here for like underrepresented languages, in particular for Ukrainian. And I think even though I think there's very much the trend that we can kind of go towards more fine-grained and finely granular modeling of these languages, there's still a lot of challenges and very high-level and like obvious challenges like this language confusion that I mentioned before, particularly for underrepresented languages and languages where we don't have so much data available. And errors that we observed for Llama 4 and like iterations of Llama 4 that we are developing still relate to kind of more fundamental concepts, like even some like grammar errors relating to formality or fluency as well. And I just want to show you here a couple of examples for Ukrainian to give you an idea that there's still a lot to be done there for really making sure that these models are equitably fluent in all of the languages that we want to represent. And so for Ukrainian, and I apologize here, I think I can only give you a very broad overview. I think all of you know much more about Ukrainian than I do. But we've observed issues related to general grammar issues related to the gender in particular. We found that the model often assumes kind of in the default setting that the user is often masculine, and so there are conjugation issues or issues related to gender agreement. In different settings that should be here, where the user actually, the prompt indicates that the user is female, but the model doesn't take that into consideration. Similarly, for other like declension issues, we've seen that like in very simple cases here, like in like relative or like locative clauses, basically where the model makes simple like grammatical errors. Or even for like relative pronoun declension, where it's not able to appropriately decline the language here simply because because it's not something where the model has seen that much data in post-training so far, but it's something I think with additional data and with additional emphasis to improve its fluency can definitely be improved. Beyond these kind of very surface level like grammar issues, there's also kind of more contextual issues regarding how the language is used. One part is related to just formality, and in particular dealing with kind of different contexts where we want to use like both formal and informal language. And one thing that like the model hasn't been trained explicitly for instance, is to use the correct form of like formality across the board. So we've observed some inconsistent usage of formality across different instances here. You can see one example of I guess a more personal or like more informal prompt here, where the model responds in a more formal setting than perhaps required. But then at the same time we have kind of a setting that in other settings where the model might reply informally. And so it's still something where if it's not explicitly trained for or encouraged for, that it can expose inconsistencies in the model's behavior or the model's personality to these users that don't directly transfer across these different languages. There's also other issues that kind of relate to generating different forms of content, where some of the like practices or standards from English don't really transfer readily to other languages. And even kind of in very common settings like simply generating a message or an email to your boss, they are kind of more like obvious errors still, like not really generating the right form of address here, where the model uses or basically starts to fill in with the last name of the manager, which is not really appropriate in this context. Lastly, we've also observed, generally, I think the quality of the generations of these models is already like often fairly natural, except for some of these like grammar issues that we mentioned before. But nevertheless, there's often some issues that still relate to fluency when it comes to the overall like coherence or the overall structure of a text. So in some responses, we've still seen that the model has a somewhat repetitive sentence structure, so it might repeat certain kind of common formulations that maybe in isolation are fine, but then if they kind of reoccur in a response, or if you see multiple responses that have the same patterns, don't really feel as natural or as fluent anymore. So again, this is kind of the need for doing more, not just modeling like a single turn, but actually modeling and training the model on multi-turn conversations. And finally, I think there's also still like issues regarding like diplomacy and most acutely the representation and of different idioms. So here is a prompt, for instance, where we ask, where we provide a hypothetical situation where a friend is grieving, and we ask the model to respond appropriately here using a local idiom in Ukrainian. And you can maybe think if there's some idiom that you can think of, right? Something to console the friend would probably most likely be appropriate in the situation, or something that gives hope potentially. But what the model generates here is or it comes up with is the idiom all that glitters is not gold, which is not really related to like sadness and not really like contextually appropriate in this context. So I think if you, in many cases we've seen, if you ask the model maybe for the meaning of some idioms, it's often able to give you that, but then actually connecting relevant situations or like with locally appropriate context or locally appropriate like more idiomatic information is still a challenge for these models in underrepresented settings, and here particularly for Ukrainian. And so with that in mind, that is not to say, I think, that particularly for languages with fewer data, still kind of on the first part here, just improving performance on the language level, there's still a lot of room for optimization here. And but now I kind of want to go to the middle part here and talk a bit about how we can go beyond languages and actually model and take into account different dialects. And this is also kind of depends a bit based on the language, right? For some languages, there are clearer dialectal differences than for others. And what we focus on here is Arabic, where the differences between dialects is perhaps the most stark in practice. And so for Arabic, you typically kind of have two settings. You have the modern standard Arabic, which is kind of the standard literalized form, right? If you have literary texts or like news articles, these are going to be in modern standard Arabic. This is like well understood and but typically not used in everyday conversations. And on the other hand, we have dialectal Arabic varieties, which are typically region or country specific. And you can see here different countries that we studied in this study, which all have their own dialectal Arabic varieties. And the important thing to understand is that Arabic is not monolithic again. So these different Arabic varieties differ very much fundamentally across many aspects of linguistics. And in particular, many of these varieties are actually not even that mutually intelligible. So that even native speakers may not understand or have very much difficulty understanding varieties spoken in different Arabic countries. And just to give kind of one example here that we also investigate in our study, here you can see these two English sentences across, and translations of these across 3 different varieties of Arabic, both modern standard Arabic and 2 local varieties. And in practice, if you look at the symbols, there is essentially 0 word overlap across all of these 3 different varieties. So even though they are translations, they mean the same thing. The types of characters and symbols they use here, even just like lexically, is completely different, which complicates crossing the transfer and complicates actually modeling these languages in practice. And so if we look at how the current set of models deals with these languages, it's basically clear that these models have mainly been trained on the modern standard Arabic variety. So because a lot of the text online is in MSA, and most likely also a lot of the post-training data for these models is just in modern standard Arabic. Which in practice means that if you try to have a conversation as a native Arabic speaker in your local variety, it's extremely challenging to actually get them to respond in your variety. So here is kind of an excerpt that is translated to English from one of the co-authors of our study, who can kind of native or who can speak Egyptian Arabic, and on the right you can basically see the dialectness scores. So how likely or the probability of that response or that utterance being in Egyptian Arabic. And you can see that for the user messages here, the probability is very high. So these are actually in Egyptian Arabic, just kind of translated here now. Whereas the responses by ChatGPT or GPT-4o here are just in modern standard Arabic. And only after, I think, like more than 10 turns, in the end, the response finally goes green. So only in the end, after a lot of like probing and encouraging, it finally was able to generate in Egyptian Arabic. So for this study, we basically just try to evaluate the extent of this issue. So how well our models actually able to generate dialectal Arabic in practice. And we looked at this across a couple of different facets. In particular, looking at both kind of fidelity, so similar to language confusion before, whether models are actually able to generate in the target language variety, how well they understand text in the target language variety, the quality of understanding, and whether they're also able to transfer between modern standard Arabic and different dialectal Arabic varieties, using kind of a combination of these generation setups that I mentioned before, as well as translation setups and some human evaluation settings for settings like instruction following and fluency that are difficult to capture automatically. And here are basically just some translation results to illustrate both the understanding and the fidelity part here. That you can see here on the left to English from the variety and from English to the Arabic dialect varieties. And if you kind of just look at the high level here at the height of the bars, you can basically see that to English is much easier than actually generating text in a target language variety. So meaning, and we can see a similar thing for or kind of a related thing for generating between dialectal Arabic and modern standard Arabic, where scores are kind of low on average in general. You can see here a dotted line that uses just simple baseline of copying the source. And in most cases, actually, the models are just barely able or not even able to outperform the simple copying like copying the source text, which is not in the right variety or not in MSA. Generally essentially showing that these models, because they're able to translate from like to English well, they're able to understand this variety, but actually generating into them is extremely challenging for them, because arguably, or the assumption is that they just lack the training data or have not really been trained to actually generate in that data in that variety reliably. We've done kind of an additional human evaluation to complement those results, and you can basically see here kind of the performance scales for each capability, for fluency, adequacy for MT, the fidelity and adherence to instructions from red to green, and then the icons of the different models depending on their ability to do well in these. And kind of the main high-level thing here is that models are able to produce outputs that are generally fluent and kind of adequate or adhering to instructions for in those cases. But what they are mostly struggling with is really the dialect fidelity part. So even across all the models that we evaluated, they are generally not able to really consistently generate data that's in the right dialect variety. And I think this kind of demonstrates interesting reversal of what has been termed this generative AI paradox, which basically found that models actually, because they've been trained on a lot of expert curated data, that they are able to generate expert data or like expert looking data across different tasks, but are not actually able to like truly understand or like evaluate that kind of data or those generations appropriately. And in our setting, we basically find the opposite, that models are able to understand dialectal Arabic because in the pre-training they've been exposed, at least to some extent, to those varieties, but they are very much impaired in their ability to generate this dialectal data. And we've seen here that, similar to the language confusion study that I mentioned before, doing some few shots, including some examples of this behavior in few shot prompts, improves this performance. So you can see here the few shot results in red and the zero shot setting in blue here. So we get kind of these improvements with using future prompting. And what we didn't do here, but similarly to before, also just simply including more of this data in post-training, also improves results. But if you can, if you can make out the values here, these are still ranging from like 0.4 to 0.1. So there's still very much large headroom for actually improving and making this generation much more reliable and actually probably improving dialect fidelity here. So with that, I want to go just from the language space, just and talk a bit more about actually representing or evaluating on local knowledge. And just briefly, I think most of us are aware that a lot of the canonical datasets that are being used, such as MLU or its multilingual version, like Multilingual MLU, which is just a translation of the MLU dataset, are translated, and because of that are essentially like both translationese in the natural language data quality, but I think more importantly are kind of biased types of knowledge and concepts that are represented here is biased based on the original data set, which is typically Western-centric. And even though models currently can do very well on this multilingual MLU, this doesn't actually really reflect the actual multilingual knowledge and the real world distribution of multilingual data across those different countries. And just to give a few examples here, we can see instances of these cultural biases in MLU just across the different categories in MLU. For instance, in professional accounting, we see references to just articles that are just very US-centric and not really well known outside of the US, or a whole category being about US high school US history, which also mainly relates to concepts that people in the US are familiar with, but that are maybe less well known to speakers of other languages or based in other countries. So for this study, we basically try to analyze the cultural biases that are inherent in MLU and essentially create a kind of more culturally sensitive and culturally agnostic subset of these. So basically subsets that both contain a lot of cultural questions that require cultural information, as well as subsets of the data that are completely culturally agnostic. And we looked at 3 different types of cultural or language-specific knowledge, including cultural knowledge here, that is based on the cultural conventions of language, knowledge about kind of more the locality and the region and cities and places there, as well as knowledge about specific dialects. Just briefly, here's just for information, the data was annotated with at least 3 annotators, and generally, interestingly enough, the highest agreement was for anatomy. So for more STEM-like subjects, annotators tend to agree more, and the highest disagreement was for scenarios where there's perhaps a bit more ambiguity, particularly moral scenarios, as well as for high school history, where perhaps fewer annotators are that familiar with the final responses. And the main findings are basically that about 1/4 of MLU actually requires cultural context to be answered correctly. Okay, sorry, I don't see the chat, so if you have any comments, let me know. And basically you see the percentages across different types of cultural information that I mentioned before, where here you can basically see the different categories sorted based on the cultural information that is required, with world religions and moral scenarios requiring the most cultural information in practice, and on the right-hand side having STEM-like subjects like math or CS or medicine requiring basically no cultural information whatsoever. Furthermore, as you perhaps might expect, about 85% of the questions actually the cultural context required is Western-centric. So this and in most cases just relating to North America, while most of the other regions are dramatically underrepresented. We also see that culture-specific information is overrepresented for certain countries. Within Asia, it's India, and Middle Eastern cultures, there's a more equal representation, and for Western cultures, US and the UK predominantly. And finally, also the cultural sensitivity varies across subjects. So for humanities and social sciences, they required this cultural knowledge, as I mentioned before, and STEM and medical generally did not. So finally, I hope I was able to give you kind of an overview of where I think some of the multilingual research is increasingly going in terms of increasing really the granularity and going beyond kind of more language and more like general and English-centric information, more towards the local context. And I just mentioned now some work that basically focuses particularly on the like dialect or local knowledge dimension of this spectrum. And I just want to highlight here a few more examples by both colleagues at Meta and like external collaborators, including that cover some of these dimensions as well, including Multilocal, which is a recently created dataset based on Wikipedia that has been created based on Wikipedia articles that are popular in those specific countries, and that represents more locale-specific knowledge to kind of serve as a counterpart to some of the translated factuality evals. In addition, on the translation side, I mean, Meta has a long history of developing models and benchmarks for massively multilingual evaluation, including Flores. And this is kind of the latest in that line, Bouquet, which now goes beyond English-centric translation and covers diverse domains and registers. And it basically covers already these languages and is continually being expanded by researchers at Meta as well as the community. And also there's kind of a large-scale effort to collect kind of a multilingual or like a MMLU-like dataset covering exams, but now exams that actually have a more appropriate representation across different countries and regions, including professional certifications and licenses like driving licenses across different countries. And this is a massive crowdsourcing effort that now also covers a lot of other languages that are typically underrepresented, like languages from Africa. Finally, so we basically see, I think there's a really increasing effort on this kind of middle part in terms of really representing and doing things, both benchmark building and modeling that is represents local knowledge or that is more culturally aware. But I think so far there's like very little work that really like goes all the way and that looks actually at like specific users or more like personalized settings, where I think we'll see more work going over the next few years. And so with that, I just want to kind of end with a few like high-level remarks. In particularly, I think the kind of the beauty, I think, for doing like multilingual NLP is really that it allows us to both cover like breadth and depth. So breadth in terms of like the number of languages that we try to model, but also I think increasingly depth in the complexity of each language that we can model. Because now that models are really like powerful enough that they are able to produce mostly natural or fluent text, we can actually look at some of these more nuanced features of language that so far have really been like underrepresented in research, or that we were not able to properly like model or evaluate in practice, like expression, slang, formality, cultural references, and more idiomatic usage of language. These, of course, have like technical challenges in terms of how we can do annotate this behavior in both a way that maximizes inter and data agreement, but minimizes the amount of effort that is required in each setting that we try to tackle, designing reliable and robust evaluation methods that can work for automatically evaluating these very nuanced sets of behavior, and then in the end ultimately designing rewards or data that allows us to optimize and train for these aspects of language. Finally, I think as a community we can really focus on kind of developing models that are now ever than before more useful to speakers in their local context, And I think for where we can get inspiration maybe from that is really looking at cases where current models are struggling and breaking down, and letting us get inspired by use cases that are either not possible currently with current LLMs or simply not considered in kind of the mainstream line of research, and really looking for what type of information is required to tackle them, as well as what types of interactions or human in the loop scenarios maybe that they might require. And in the end, I think we can, I think one approach can be to really go deep and really deeply understanding the language and the language variety and its limitations and complexity, and then trying to see how those characteristics and those kind of modeling choices and methodology can be applied and can be made scalable to other languages. So yeah, that's the end. Thank you so much for having me, and thanks for listening to my talk.
Thank you so much, Sebastian. There's a round of applause here. I'm not sure you can hear it. And we have 12 questions. We are at time, but I think we have like 10 minutes of buffer time. So I think it's okay to go through the questions if you don't mind. Could you stop sharing your screen? Yep. Thank you so much. Just a second. Okay. So hopefully you can see the questions on the screen. Yep. Okay. So I'll go from top to bottom, and some of these have been hugely upvoted, as you can see. So let's start with disinformation. How do you approach data QA with Russian Pravda injecting 3.6 million disinformation articles, causing chatbots to repeat false narratives 33% of the time?
That's a great question. I mean, I think factuality really is still like a big failure mode, big limitations of these models. And I think particularly when it comes to factuality about like more recent news or like more local knowledge, which typically there's fewer sources on that, and also there's less knowledge about like on the pre-trained data on that. So that's something we're actively dealing with. I don't think we have a silver bullet in that. I think it's kind of like multifaceted approach in terms of both improving like retrieval or the like filtering relevant like websites or reputable websites to get that information. So to not consider disinformation articles or like those sources like at inference, and at the same time allowing the model to perhaps, if it doesn't know or if it's less confident in its responses, to decline to answer or say it doesn't have information rather than making up or repeating some of those falsehoods. It's something I think even for English is being optimized for, and I think in the multilingual setting there's just much more, both in terms of the availability of information, as well as just the right variety of like topics that we need to deal with that makes this much more complex. So it's an ongoing challenge, something that we're working on. Definitely I think I think for now we're still far away, like some ways away from actually like guaranteeing or like generating responses that are completely factually accurate in all cases.
Thank you. How do you define internally if a model supports a language? Is it based on evaluation or amount of training data or presence of instructions for a language or something else?
Mm-hmm. That's a great question, and that's something that is a bit. I mean, like I guess each lab or each group have like their own sets of characteristics or settings at Meta, and when it comes to like Llama, or also like Meta, like the Meta AI assistant, and when it comes to launching actually models in different languages, we basically have set a quality bar that covers kind of the like most important capabilities and like includes, I think, some of the like types of evals that I mentioned before, right? Both like existing capability evals, but also like user-based evaluations. And so we kind of set, compared to like English or compared to other languages that we have already launched, what we would expect the performance of a new language to be like. And that combined then with also the like safety evaluation, right? I mean, we want to have like natural, like performant, like useful responses, but we also don't want to produce like falsehoods or generate data that is like offensive or harmful. So all of these kind of make up kind of a quality bar, basically, that if in order to launch a new language, it needs to be like above those across different settings. And if there are things that are not there, or that the model is still failing on, we basically need to improve and optimize on them until we are above that bar for this language.
Well, thank you for, by the way, thank you for the diversity of llamas and diversity of languages in your presentation. That was nice. Can you rank the reasons for language confusion? Is it insufficient training data in a given language, or poor token vocabulary, or something else?
Yeah, I mean, so in practice, at least, I think the most important thing, I think, is the presence of post-training data in that language, because, like, as you've seen in the evaluation, basically where this behavior is most frequent is for models that are really trained English-centric, that mainly have English-centric post-training data, because effectively it's, I guess, a setting that is like instruction following, like, right, where in user conversations you want to like expose the model to be able to like generate or show it how it should respond in these conversations, and perhaps it might have seen some similar like dialogues in online, but if it's then only exposed to English post-training data, it just learns to generate mostly in English. And so we actually saw, for the dialectal Arabic models, that the base models were actually better at continuing to generate in dialectal Arabic than the instruction-tuned models, because compared to the instruction-tuned models, the base models had been trained to like complete a sentence, where if this is dialectal Arabic, due to like the pre-training, it would also try to continue this, while the instruction-tuned models had been trained or exposed more to like modern standard Arabic, so they would be more inclined to continue this in like standard Arabic, basically. So I think post-training really has like the biggest effect here, but I also think, particularly when it comes to some of the, I didn't show examples here, but in the paper we have some more examples, and actually looking into what I think is the more interesting setting of this word level confusion, and that I think I have less clear of an understanding of under what settings this model actually like makes these random like word switches, which most often like happens with English, and where I think this is a bit more perhaps like an artifact from pre-training of the different like token level capable like probabilities across different languages, perhaps not being fully calibrated, or the model having less data in that language, so that even if it actually generates a text in that language, and where all the tokens in that language should have a much higher probability than tokens in any other language, somehow in certain situations, some tokens in English might get a higher probability than tokens in the same language. So I think there's still something there in terms of like calibration, presence of pre-training data that is not, we don't have fully understood yet.
Thank you. Are there plans to make any more dense models like Llama 3, or from now on Meta would stick to the mixture of expert models?
Yeah, that's a good point. I think it's generally there's generally kind of like exploration or experimentation with like different architectures and different varieties, right? I mean, you've also seen even things like what Luke presented in the keynote in terms of like new architectures like this byte latent transformer, right? So there's kind of general exploration on that. It is to be said that with like for these kind of large scale settings that Meta is interested in terms of like production settings, mixture of experts are very favorable. But on the other hand, I think there's also kind of a similar sentiment that perhaps mixture of expert models, how to really optimize them at this larger scale, and particularly when it comes to training like multimodality models, it's perhaps less understood than really scaling dense models. I'm not kind of party to like all the plans in terms of like future model releases, but I would expect still that there's going to be some more model releases at some point that also serve settings that are where Llama models in the past have been really successful, right? More the smaller deployed settings of like deploying models in more memory constrained settings, where dense models would be again like the best architecture. So I would expect that we will see more of that again, but I don't have any any personal knowledge of those efforts right now.
Thank you. That would be much appreciated. Backbench found 62% of code solutions incorrect, vulnerable. Is this a training data issue with models replicating security anti-patterns from open source repos? Not sure this is a question for you, but maybe you have thoughts.
I mean, yeah. I think just general like data quality, particularly when it comes to some of these more, I guess, really like task-oriented settings like code completion or code generation, I think is really crucial, and that's I think where, given that like architectures are mostly like relatively stable, there's less things that you can potentially do there. Actually making sure that like the data that you have doesn't represent like anti-patterns or doesn't allow you to introduce potentially like harmful biases in the model is really crucial. Yeah, I'm less aware of the particular efforts on the coding side, but I think they're definitely working on kind of cleaning up and making sure that actually the data that is used for training, that solutions there are correct, or perhaps like have a lot of unit tests that can actually be used to verify some of these or identify some of these incorrect solutions.
Mm-hmm. Got it. The common theme for today's talks is compute resources constraints. How can researchers collaborate with Meta and launch multi-building 32K GPUs training jobs?
Yeah, good question. I mean, Meta, I think, still has through like FAIR, right, a very active like research collaboration and a lot of work on like models and data sets that are also being open source and shared with the community. There are, I think, in the past have been programs where like research efforts get budget in terms of like compute or like credits for using Llama models. I think some of these. I'm not sure which are the like most current setting there, but generally like there is kind of the purpose to support the open source community and really enable and further grow the ecosystem around Llama models. So I would recommend you to like basically look for grants or look for collaboration settings like that. And I mean, also beyond that, maybe for looking at other communities where larger amounts of researchers are collaborating and potentially like Mazakane or like the AI community, where maybe some of these resources can be shared or models can be trained in more of a collaborative fashion.
Actually, also Llama Impact grants are available for Ukrainians to apply for starting last year. So
amazing.
The program continues this year. That's a good opportunity for everyone. What do you suggest Ukrainian researchers do to enhance local models?
So I think the first part really like what I touched on before, like if we can't measure something, we can't like improve that. So just building like high quality benchmarks for Ukrainian that actually expose or evaluate some of the aspects that are not captured by current benchmarks that focus more on often like more broader sets, and also like for different like types of knowledge, right, for factuality, but also I guess now maybe for reasoning, right, more cultural related or linguistic reasoning for Ukrainian. So I think that's the first part, because that's then something that I think everyone can will be able to make use of. And then I think beyond that, looking once those benchmarks are available, I think there's still a lot of potential work just in terms of the space of at Meta, right, we're trying to focus or trying to develop models that can do well like across a lot of languages, right, but often that means making trade-offs or maybe being able model still needs to be very good at English, and on the other languages we still need to like retain performance in all of these. So I think there's still a lot of scope for actually developing like fine-tuned models for specific languages like Ukrainian or specific language groups, maybe like Slavic or Eastern European languages together, and really trying to see how we can maybe prune the models, like make them more efficient, just focusing on those languages, or really like enhance them by leveraging resources just targeted for those languages. And I think that's where we'll see the biggest benefits. And I think if we have evals that really capture these more like cultural nuances, where I would expect to see the biggest differences by doing this more targeted training and fine-tuning.
By the way, you mentioned the exam multilingual benchmarks for using exam tasks. So we have at least 2 for Ukrainian already that are open sourced, and we're like very open for collaboration to have Ukrainian included everywhere in all places where possible.
Amazing.
Okay, how do you handle cross-cultural work scenarios where location-based context can backfire, like validating poor Portuguese text while metadata in Ukraine?
Yeah. I mean, yeah, good point. I think that's really where I think in practice the complexity really lies, right? Where I think if you do things like on the language level or even region level, you can still kind of control for that. But once you try to take into account like the metadata you have on users or like the location context, there's all kinds of different scenarios that come for that. I mean, also whether someone is right, whether they're in Ukrainian and they're a foreigner just coming to Ukraine, or actually like a native, right, the type of knowledge or the type of responses that you would want to provide for them, like differs a lot based on that, like that context as well. So it's I think kind of really making full use of this like richness of information and like data is something we are only just at the start of, and I think it's going to require more, like a lot more iteration on that. And I think that's something where if academia also like in parallel starts focusing on how we can balance these things or think about that, I think this would kind of enable everyone to get a better understanding.
Thank you. Provocative question. Google is going back to encoder-decoder models. They give slightly better result. Llama 4 uses decoder-only architecture. Do you think Google's way is better? That's a good question. I mean, I guess there's been studies also, I think, I remember from some years ago comparing like decoder-only and decoder models where, like depending on the setting or like depending on the inference or how you can like optimize or make them more efficient, right? There's some like slight differences. I mean, I think the Llama 4 models might use this architecture and they're out, but it doesn't mean that like Meta is going to stick to that architecture. So I think they're definitely going to explore. Like I'm less working on like the actual like architecture, but I think they're definitely going to explore like different combinations and kind of looking at what actually works best at scale with the infrastructure or the compute settings that are available at Meta. So I could very well see if encoder-decoder models in those experiments turn out to have the edge to have them to switch again. But it depends. Okay, it depends. How do you estimate language confusion for the multimodal contexts?
I mean, great point. That's I think something. I think in the multimodal context, multimodal adds like more complexity. Often, it kind of depends like which particular like settings they are. But often you might just have a. I mean, you can imagine right scenarios like on Facebook comments or like on Instagram where you have some video and then only some. Like a caption of that video or just like a very brief comment, right? So the language doesn't really give you that much actually, and I think so in that context, either like just understanding the video, like having the context of the video is going to be relevant, but also just more of the, I guess, conversational history, because in some cases, right, the user might ask you to translate something about or ask a question about the video that is in a different language. So I think in this case probably like a bias towards what is based on the prior conversation context, what is the preferred language of the user, and probably using that as the default. But I think depending on the use case scenario, I think there's very interesting model challenges, particularly at the tail.
Mm-hmm. Thank you. We are unfortunately at time, so we will have to skip one of the questions. I'll just note, here we have a note that AI at Meta QR code that you had on the slides leads to, sorry, our site is not available in your region at this time, and this is Germany. Would you double check that, please? And
okay.
There's a question whether you would be comfortable sharing your slides with the community. We could, if you send them to me, I can post them on our website, if that is okay.
Okay, cool. Yeah. Let me just. I need to check internally
because
I'm not so sure yet. But like happy to share otherwise. Yeah.
Thank you so much. And when Llama 5 will arrive? I have trust.
Yeah, I don't think there's no clear timeline on that yet. Yeah.
Okay. Thank you so much for your time, Sebastian. We were very
Yes.
happy to have you.
Thanks so much, and yeah, I hope you have a great rest, great break, and great rest of the workshop as well.
Thank you so much. Okay.